The base. Start with a wooden base, 30 centimeters by 17.5 centimeters at least. Drill 4 holes with 5/8 inch diameter into the base. They should be an equal distance apart. As well, they should be placed on a circle that is centered around the middle of the base. Screw bolts with the same diameter into each of the 4 holes. This will require some elbow grease. Then take copper magnet wire and wrap each bolt 200 times. When doing this, there are a couple things to remember. Alternate the direction you are wrapping on each bolt, clockwise and counterclockwise and so on. The reason we do this will be explained in the second part of this video. Also, to help wire stay, place dabs of nail polish at various points on the wrapped wire. The next step is to screw in a screw in the center of the circle that the bolts make. Because the screw can change height, it will allow adjustment to the distance between the coils and magnets. The frame. Now we will look at making the frame. Obtain 2 pieces of wood with dimensions 23 centimeters by 4 centimeters by 2 centimeters, as well as another piece that is 17 centimeters by 4 centimeters by 2 centimeters. Drill a hole with 3/16 inches in diameter in the middle of the shorter bar. Now, nail each end of the shorter bar between the 2 taller ones. Make sure there is a clearance of at least 21 centimeters under the top bar. As well, the top bar should be able to twist. Now nail the bottoms of the taller bars to the base. The hole in the shorter bar should be directly over the screw. The spinning part. Create a wooden disc with the same size circumference as the circle that the bolts make. Drill a hole in the center of this disc with a 3/16 inch in diameter. Use a hot glue gun to attach 4 coin-shaped rare earth magnets an equal distance around the edge of this disc. The poles of the magnets that are facing down should be alternating so that it goes north-south, north-south. The reason for this will be explained later in the video. Next, create a metal rod that is 25 centimeters in height, as well as 3/16 inches in diameter and has a pointy end. Warning, do not use a wooden dowel as it will most likely break. Stick this metal rod through the hole in the disc and use hot glue to secure. Cut a sturdy water bottle's top off and then cut it in half. Glue this to the rod as well as the disc. Place the spinny part in the frame that we had earlier created and voila, you have a generator. To prove this generator worked, we hooked up the 2 free ends of the wire to a voltmeter and blew a leaf blower at it to create artificial wind. As you can see, it works quite well and creates around 2.7 volts and 100 milliamps. Let's start with the basics. Electromagnetism relies on 2 things: magnets and conductive materials. A magnet is an object that possesses a magnetic north and south pole. Electromagnets are also magnets. An electromagnet is a coil of wire usually wrapped around a ferrous material that produces a magnetic field when current is run through the wire. The magnetic field that is created around any magnet looks like this because the field lines go from the north pole to the south pole. The conductive material used in electromagnetic devices are coils of copper wire. Coils of wire are called solenoids. Generators are simple devices which use these 2 components, the magnets and coils of wire, and rely on the principle of induction to create a current. According to Faraday's law, a changing external magnetic field near a solenoid will induce current and voltage. Therefore, a magnet moving through or by a coil of wire will induce current because of a magnet's magnetic field. A coil of wire is at its happiest when it is at an uncharged state. When a magnet is moved through it or by it, the coil wants to resist the charges put on it by the magnet. This is explained by Lenz's law. Lenz's law states that a current will be set up in a coil of wires to oppose the charge of an external magnetic field. As the north pole of a magnet approaches the wire builds up a current to make a north charge to repel the magnet. This is called induction and produces electricity. The same occurs with the south pole of a magnet. Now that we know the basics of electromagnetism, we can explain exactly how our generator works. Our generator uses the principle of induction to create current. As we already know, as a magnet passes over a coiled wire, the wire creates a current to make itself in the same pole as the magnet's repel said magnet. As the magnet leaves the coil creates current in the opposite direction to keep the magnet where it is. This is why our generator creates alternating current, because the current changes direction. The magnets are alternating north-south, north-south, and the coils are wrapped left-right, left-right, so the greatest change in the magnetic fields around the coils occur. The greater the change, the greater the induced current. Generators are used in everyday life. An example of this are windmills. Windmills convert the power of wind into power that can be used in your home, much like our generator does.